we can chat. This is the Nephew SDK meeting for November 14th, 2023. Yeah, so I did that yesterday. So if recall last time, right before KubeCon, there was a I think we said let's kick off POC, and then the response from them it was oh let's put it into writing and see what it is. So I figure so what I was asking, what I was talking about last time is we want to, so Fiacra obviously has been doing POCs anyway, so I don't last time as we talked about, we don't want piecemeal point POCs. Let's try to do a POC where is, you know, can we do this more of an end-to-end type thing, at least even if there's a lot of missing pieces of an end-to-end, at least we'll know what it is. So I sketch out 4 cases from the perspective of how this would possibly work. And so there are 2 cases where we'll actually execute Helm on the management cluster directly, or 2 other cases where we are doing Helm on the workload cluster. So that's how I kind of divided up on these cases. So in this case, when you are onboarding using Helm, the Nephew SDK would be taking the Helm charts. So this is this over here. We'll be taking the Helm charts. I'm guessing you can see the mouse moving, right? Because I have no idea what I'm sharing.
Yeah.
Yeah. The thing about the Zoom is it doesn't show you what the sharing screen is for the presenter. Whereas shameless plug, Google Meet, they'll show you that screen also. So in that case, it generates 2 things, right? So my perspective is, if you are doing a full integrations, somewhere you have some business logic that needs to take in the Nephew CL, which right now is just NF deployment, needs to be involved somehow. And then so in this particular scenario, it could be a mix of the cases, by the way. So while thinking about this this morning when I drop off kids, I thought, hey, we can combine those things too. But let's go over this first. In that case, you're generating the business logic. What is the business logic? And business logic is basically just take in, you're exposing KLM resources. So at the very minimum, your values.yaml and the possible input parameters for your Helm charts needs to be in some sort of KLM format, so users can configure your values.yaml basically. So you expose that as a KLM resource. It doesn't necessarily need to be a CLD, but that is KLM resources. And your logic, you need to have some logic, because this particular case scenario is the Helm is executed on management cluster. So in that case, you're basically creating a Helm install, a Helm template. So the idea is your business logic takes the translations of the input KLM and generates a values.yaml. So let's say, for argument's sake, case 1 is using Operator SDK. So the Operator SDK generates the CLD, which would be the values.yaml. And then after user manually input, let's say we're not even doing anything fancy, so user manually input those parameters, you execute the Helm operators, and then it generates the, so in that case, actually, the Helm operators need to have the kube config of the workload clusters, and then they will apply the resource. And at the same time, your business logic would also be, as part of the package that you have, you will also be generating a Nephew CL, NF deployed. So what does that mean? It means that the Helm does the day 1 operations. It will bring up the network functions. But then after that, at the same time, pretty much at the same time, you also apply the NF deployment, which will modify. And in that case, we'll bring up the vendor of NF operators, which takes care of day 2. because the Nephew CL hosts the intent of the deployment. So the operator monitors the network functions, whether or not it meets the deployment intent, and then it would then make adjustments for what it is. So in that case, the assumption here is you run your Helm operators, or you can even run the entire Helm client directly on a management cluster. We assume that you have the kubeconfig credentials on the management cluster. So we'll use the Helm executions to bring up the network functions, and that will be done. And then after that, any subsequent things would be on the CL changes, right? So one of the confusions of the management cluster side to me is it depends on what are we exposing, right? On the CL, on the KLM resource. So your package contains a KLM resource, a set of KLM resources that at the very minimum has to be able to give us a fully resolved values.yaml. And if we use, say, operator SDK, they translate your values.yamls into a CLD directly. So you can use that. But then Nephew operates on Nephew CL. So your business logic that runs on management cluster would also have to either the SDK has to include the Nephew CL inside the package, in which case the users would have to input the Nephew CL input, which overlaps probably greatly with values.yaml. So that's another little things that probably has to come in. But then we do want to apply that CL because your day 2 operations would still have to be carried on by the NF operator. So in this case, the reason why this is green, this is written, well, actually it's not green. So these things are written by the vendors. So although 2 different colors, but they're written by vendors. And then this is Nephew's, but it's basically all vendor stuff. One advantage, of course, is your Helm charts never really have to change too much. And in that case, one big difference between using operator SDK versus Flux is the Helm charts is bundled inside the package, or at least bundled somewhere in the management cluster, because you need to execute the Helm charts when the Helm operators needs to be able to access the Helm charts to apply the input YAML. So as I said, one of the weird thing about this is there's tremendous overlap between the CL and values.yaml. So we kind of have to reconcile that. And if we do, then the logic would becomes more like case 3 and 4, as we'll talk about later.
But it's just a quick question,
Yeah.
Stephen. In terms of the so just if I'm understanding correctly, the okay, so Helm is running on the management cluster. So the Helm operator would run on the management cluster.
Yes. Yeah.
And then the NF, so the boxing grid NF vendor, Nephew NF operator, that would need to be designed towards the
So so this is basically it's a cap function. So the most likely scenario is cap function. So it'll take the input of your Helm CLDs and the input of even the Nephew CL, and then the cap functions massage this to generate what the Helm operators require on the values.yaml CLD. So we can still bundle whatever we want here.
Yeah.
But then in that case, we have a CLD that we load onto management cluster. So that's another thing that is sort of not great using operator SDK, is that if we have a lot of Helm charts, each Helm charts generates a different values.yaml CLDs, and each of those CLDs needs to be loaded on the management cluster. So this is not my suggestion. This is one possibility, which I would say probably not great, to be honest.
But that would mean an operator per Helm chart also, right?
That's right. Yeah, that's right. Your business logic, no. The Helm, so the Helm operators, as far as I know, the Helm operator today is actually operating on only one Helm chart, right?
Yeah.
Yeah, so you're creating one instance of Helm operators for each Helm chart. So that is a poor fit for what we
Yeah.
want to do. So
Yeah.
so but then instead of doing that, you use flux. So instead of doing that, you use flux. Oh, interesting. Why am I doing this? Okay, yeah, that's the reason. Then you are, well, so this is to distinguish between the two. So you're still using the SDK does the same thing, which takes the Helm charts and generates, again, there's an alternative to that. So let's forget this for a moment. So let's say you have a NF package that contains some KLM that the vendor would define with a Nephew CL inside. Then the business logics would then massage this into basically values.yaml. So right now, the assumption is the management cluster logic would then have access to a repo, which is for Helm charts. It could be a share repo with whatever confixing is watching. But then it could be a repo where you deployment repo. That's okay too. But then basically it's a repo that I have access to, where you'll then the Helm charts needs to be loaded onto that, has to be stored in that repo. The Helm charts that are targeted, the Helm charts that you fed into Nephew SDK needs to also be here.
Yeah.
They have to be the same one. So I talk about this. You have to have some logic to ensure that whatever you read here matches whatever is on the repo. So that's fine. Not a big deal. It's just code. But anyway, this logic could also still be cap functions, but probably a controller, because I don't think cap function probably allows you to store into gig, so it should be okay. So you should be able to store the entire the values.yamls that you generated onto gig. And then now in this case, this business logic would also be adding the Helm repos, the chart CLs, the versions, all those custom resources that the Flux the Flux Helm controller exposed. And then at the same time, we also still bundle Nephew CL inside the package. So this is filled up. This also goes into your operator. So day 2 operation is done by this. So it would have the deployment intent. But then now the Helm controller from Flux is now watching the repo and then applied the network functions, the values.yaml and the Helm charts on workload clusters. Whether or not this run here or here, it probably doesn't matter that much if you have the credentials. And then the network functions would then be brought up. So bringing up network function is now not the job of the operator. It would just be sitting there waiting for this to come up and then see whether or not it matches the intent. And then it continuously reconciles the intent. So the nice thing about this, although it's still not tremendously nice, is that when you are updating your Helm charts as a vendor, you still need to run the SDK one time because your business logic may change. Your KLM resources may change, and then your Helm charts certainly would change because that's the whole point of changing. But this may not change.
But are you handing over the reconciliation to
the so day two is now, so the Nephew CL, the CLD that we're going to do, and then we should evolve it anyway. Then that's more like an R3 thing, that we should make that an important things to do, which is, if we want to, this is certainly one mode of operation. I'm not saying this is the only mode of operations, but one mode of operations, we make Helm first class citizens. Helm is responsible for day 1 deployments. For vendors that are continuously supporting Helm, which I would imagine most vendors do, then we want them to be able to still use the Helm charts. If they have updated Helm charts, they use these mechanisms to update the Helm charts, and then using SDK to generate a new KLM for that update. But then if there's no changes on the day 2 operation side, then the vendor operator doesn't need to change. But if it does, then you have to also rewrite, update your operators, and then we'll take care of all the operator updates and things. And then all the CL change, all the CL would still be there. If there's any CL changes, if you have day 2, we update the CL, and then the operators would be looking at the new intent, if there's a new intent. So that's actually, I see that as actually much cleaner, amazingly, because internally I was actually presenting something else to Google Product Manager, which wasn't this. But then last night when I was writing this, I thought this is actually kind of clean. If you're separating out the roles of the Helm chart as your day one deployment operations. So the only thing you have is a logic that generates the values.yaml. The deployment are two pieces. One of them is deploy your values.yaml. The other one is, which is, it's two different check-ins, basically, the two different commits. One of them is you are updating values.yaml on the repo. The other one is you are generating this new CL that you can apply directly onto the workload cluster. So in this case, one of the things is whether or not we want to massage this into package base and stuff like that. That's fine.
But okay. So you're purely using Flux here to deploy the chart. That's all.
That's right. Yes.
Yeah. Okay.
And it also allows you to update your charts, which is, again, we review that as I said during the summit and things. Once we onboard Helm, although we want people to transitions, we definitely see a case where it'll be like long-term supporting, because until and if and until Nephew becomes extremely popular, it's highly unlikely that people would detach from Helm charts. And then we want to be able to, because again, SDK is built for vendors, so we want vendors to be comfortable saying that I have a life cycle of my Helm charts that keeps on updating. We stop somewhere still, so we're not going to say something like, oh, you have all these new Helm features that are more oriented for day two, more used for day two, and then we'll try to support all of those. We'll probably draw a line and say no, we don't do that. There is a difference between Nephios and your everyday Helm charts, and that big difference is you use an operator to take care of all your day two reconciliations done by operators. Deployment could be done by Helm charts, which if you ever Google Helm versus operator, that's actually the most common answer you'll get. Also, which people use Helm to deploy, and then they use operators to ensure that the applications meets the intent and its operation. Yeah. So this is I thought this is pretty clean model. Obviously, there probably philosophical problem there for a lot of folks that this makes Helm a little too pronounced, too significant on the
role.
But
I guess you would still have to have some harmony between the operator,
and also the logic, the cap logic, if you will, would still be there to generate the input for the for the bring up for the deployment. When we can still bundle this in the package. We can roll that into a package, because this goes into config actually. Unless Firecrawl is a pioneer of replacing config, so you may even replace config with Flux, which is possible.
or Argo. Argo.
Yeah.
I'm looking at Argo at the moment. I guess
in either case, it's just a CL in a package that we would have. We can lifecycle manage it using regular Porch means, and then we don't have to apply. We don't apply CL directly actually. So in this case, we still want to go to a repo. So we have a history of what it is. We sync up that history with the values.yaml versions that would go into there, so we know what we generated and what has been deployed. And then the real thing that needs to happen is your operator has to be monitoring your workload and making sure that it meets the intent. So maybe we'll, as part of this exercise, along with other folks in SIG 2, we'll have to define the operator role, and then also probably would have to change the CLD a little bit. Today is just too.
So say in terms of the 3.5GC, what's this? So what's there?
So I always hated. So even when Wim and I can even put that on recording because I think he remembers that when Wim and I was writing the CLD together, the one thing that we both didn't like, but then had to do at that time was explicitly set IP addresses and VLANs on the NF deployment. what ends up to be NF deployment. Initially, I when I first proposed it out of Google was UPF deploy and NF deploy and SNF deploy. I even have capacity on different different capacity for different types. But then Vim is a pioneer of consolidating the whole structure, so that's great. So now we have NF deployment only, starting L2, but then it's still explicit, meaning that if you think about it in an operator perspective, the CLD doesn't give you a lot of room to operate.
No.
Because if you change the CLD, it goes back to management cluster, right? You change the CL, it goes back to management cluster. So what we want is push maybe that CLD to a higher abstraction. I think one of the SIG 2 meeting we talked about that. Maybe we'll have the IPAM on the management cluster give a block of IP address instead of one explicit IP address. And then if we, for example, have the lifecycle manage the network functions through the operator, and then if we have to adjust based on capacity requirements, and then say that, oh, I have to create another pod, because vendors network functions are not like 3.5GC. Your UPF is not just one pod. Your UPF is the one experience I have is 3 different vendors. They're probably going anywhere between 6 to 10 different pods for a UPF. And one particular pod and one particular vendor, one particular pod controls the N3, whereas the other pod controls the N4 and N6. And then if you have N9, probably goes into the other one, that formal one. So if you're having something like this, then in theory, if there's still multis, the additional N6s, for example, becomes different secondary interfaces that requires IP address that isn't managed by Kubernetes. So in that case, the operator may be the one that allocate from the block of IP address given to it through the Nepio CL, and then it would internally do IP address management by assigning the IP address directly to this new pod that requires a new secondary interface that requires another IP address.
There's lots of complexity there when you dig down into it. But I'm just wondering, in terms of what exists today, or what the aim for the
this is more than the SDK thing. This is a wider discussion.
Yeah, it's kind of NF. That's the NF2 infra stuff, right?
So if Victor was in the room, I guess last time when we had that post-summit discussion, I suggest this is one thing to talk about, the evolution of operator. But then it wasn't being discussed because the 3 topics that we picked that didn't win. It missed by 1 vote, but still. But I think the preview of that, I spoke to some of the people in the community already, that we do think that to kind of more strongly demonstrate the value of Nepio, we emphasize a lot on the management cluster side on L1. And then subsequently L2, whatever L2 would become anyway. But then we probably want to put a lot more emphasis on operator moving forward. And then we want to make sure that its role is significant. And it should do what it's supposed to do, which is lifecycle manage the workload. And in the context of quickly responding to the workload changes at the time that could be done within a cluster, right? You can even massage it a little better by saying that if it doesn't touch the Kubernetes API server, the operator may be able to monitor it faster, and then make some changes directly by sending config changes, right, to the network function. Network function config changes, not Kubernetes config changes. So I think we have to identify use cases. I think service assurance guys are talking about some use cases like this too. Obviously, Tao is a major advocate for having a more powerful operator, which I do too, because when we launched the project, that was the idea. And so that's what I would like to see. But this is a bigger discussions. But I do want to put that out so that we have to create CLs that are high level enough, if you will, so that the operator actually has something to do. And then so now that the operator has something to do, then we can think about maybe for day 1 operations, if the vendor choose to do so, offloading that into just a pure Helm experience would would be perfectly fine. Where we still have the logic that we would go through the PVSPV pipeline, the config pipeline, to populate a values.yaml instead of a destination is not really a package, which is
just on that we have another EST member looking at the. I think John started work on the gen config map care function. So we're looking to extend that to possibly
generate values.yaml.
well, accept input as YAML, you know, from a YAML file maybe, and yeah, and
yeah, there are frameworks to do so, and it doesn't deviate from Nephew philosophy.
Yeah.
We are putting it just so happened that the actuation is done by Helm instead of like an operator in that case, which is still an operator actually. In that case, on Flux case, it's still an operator, and it just takes in the Helm charts directly from the repo, and then it manages it, and it also gives us a better. So in this case, if you want to put in the IP, if there is an IP address requirement, which I would imagine so, for your values.yaml, then the initial allocations would actually be done by the business logic or a generic IP address logic, which I'm actually a little iffy on that. I would think it's probably better for the NF vendors to write this, because you have to understand the Helm values. So if we create this, deployment is something that we don't see a lot of changes to, hopefully. Whereas the network function configurations are probably something that may change a little more frequently, if it does at all. And then we'll take that as the automation of that using operator is our value, and also something that we need a lot of evolutions to get to moving forward. Anyway, so this is
No, I have like a question. Well,
okay.
The way that you describe this is like the Helm component that you have in the workload cluster. It is going to once that you deploy like a NF package or whatever, so that Helm component is going to pull the resources from the Helm chart repo and the management cluster.
Yeah, so the Helm chart would be stored in the repo in that case. So there'll be some logic. So some controllers that needs to sit and ensure that before you certify this to go in, because this is committed. So this is like committing something on deployment repo, because basically you're saying that I've already prepared the entire Helm charts and all the values.yaml, and then I'm ready to deploy. So at that point, prior to this, we have to make sure that the Helm charts on here is actually matches whatever is being read by the SDK over there. So then must be done with the controllers on the management cluster side.
So regarding the direction of the arrows are fine, like it's from the management cluster to the workload, or
so in here, so this is I should probably have something better. This is a drawing, so I can just change it directly. So in here there'll be a values.yaml being committed.
Okay.
So this is this arrow, and then once this is committed, this arrow tells them I'm ready to deploy. And the thing I want to deploy is this repo, this Helm charts, and this Helm charts directory with that Helm charts or completely new repo would also contains values.yaml, which is fully populated. So the Helm operator in that case just read from the repo and then apply and then brings up the network functions. So this is exactly the same as how you would do a Helm install by human, but instead now you involve Nephew to automate the input.
Yeah,
probably. Would it? Sorry. Go ahead.
Yeah, go ahead.
No.
Sorry.
The only error that I should change the direction should be from the Helm in the work cluster to the Helm chart repo, like that. Yeah, that one. So because you are pulling the information from.
Yeah.
Just on
this guy reading something from here. Yeah, that's right. Okay.
Yeah, on the values YAML, does it need to be committed to the repo? Because we can, as part of if I can remember correctly, the Flux Helm release custom resource, you can define or you can pass a config map ref
Okay.
as
Okay.
part of that. You know what I mean?
I
So
mean, you know that better than me. So if it is,
I'm
then
pretty
that's
sure. Yeah, we can like so it, as part
Yeah.
of the package, you can
and
you can
we don't need like this Helm that this we can basically push everything down to the deployment repo. So all we have to
Yeah.
do is to ensure that
that
the
the
Helm
chart is available.
yeah
Yeah.
the Helm repo.
Yeah.
So if we have to, we may actually write some. It's still probably better to write it on management cluster, which ensure that the Helm charts it matches the Helm charts that we're expecting that is on the repo. That's
Mhm.
basically it. Yeah, and then yeah. So if it does, then now your values.yaml also comes in as a config map through this package, right? So this will be reading from the config map and understanding that this is the chart I'm going to use, and it will apply that config map values.yaml into the Helm charts. So
Yeah.
that actually is cleaner. So that's nice.
Yeah.
So
Yeah.
we'll then store everything in a package on
Mhm.
the deployment repo, and it will be able to reference the history to see what is our input to. This is actually as close to an FU as possible already. Yeah, because that package format is basically it allows us to the Helm is not packaged inside, but then the Helm becomes some sort of our KIM resources that sits on the repo also, quote unquote. It's not. Then it's quote unquote a reference point plus our input, which is also referenceable through Gig. Yeah. So this is one, which is the one that, as you can probably see, this is probably the one I would favor right now for Helm onboarding. The other one is
So Stephen,
go
before we
ahead.
go there, if you don't mind,
Mhm.
sorry, I was going in and between. So would you, I mean, even for me and also for the benefit of others who will go through this, can you explain a journey through this? Let's take one simple example. Let's say UPF 35GC, let's say
Yeah.
there's a Helm chart,
Mhm.
and then from that Helm chart, we are using it to deploy that network functions using Nephew.
Yes.
So can you explain the steps, the journey?
So there is a Helm chart. So you're pointing, the SDK points to that Helm chart. So we'll be able to read from that Helm chart and generate a KIM resource that represents the values.yaml. And then SDK allows you to also extend this. So you're creating a vendor logic, a vendor extension if you need any, plus the values.yaml CLDs. And then so here's actually a much more strange explanations. So I actually, so internally when I said this, a lot of people said it's way too complicated. So I also want community to think whether this is too complicated. So this is based on the Operator SDK thinking. So Operator SDK works because it has an automation tools already that takes the values.yaml and creates a custom resource. And so that custom resource represents the values.yaml of the Helm charts that you point to. So internally when we go through this, or externally, some people heard me said that too anyway. I was saying that, hey, let's make NF the Nephew CL.
Sorry, I was just saying
you just want to see the flow of the deployment. You want to see you only want to see the flow of the deployment, right? But not what we generate. Okay.
Yeah.
So we generate something. So that's a package. So that package contains enough KLM resources to both satisfy the Nephew CLD, the Nephew CL, as well as the values.yaml. So that goes in, we go through the specialization pipeline.
Okay.
Part of that pipeline is as the SDK will insert the vendor logic. The vendor logic would be doing something very simplistic. It will take whatever that the KRM resource has been exposed by the package, including Nephew CLs, like NF deployment, and then get those input through whatever means. So either user manually put it in, or there's some controllers that we do that automate the process of inputting, of generating those input. And then once those logics are in place, this logic.
When you say input, the input.
Yeah, those inputs are in place. The logic, which most likely is a CAP function, would be taking those inputs and then generates a Nephew CL. NF deployment, and then also
Okay.
the values.yaml that is needed by the Helm charts. So on 3.5GC and UPF case, it's incredibly simple, but still there's a set of input. So those input to like N4 IP addresses and 3 IP addresses, the image path and things like this would all be generated by this logic.
Yeah.
And it becomes as Fiacre said, it's a config map that we can bundle alongside with the repo. So now this Helm chart is not stored anywhere by the SDK. So telco users are responsible to say, oh, I'm using 3.5GC UPF. So I have to, and I'm using this version. So I'm responsible to also copy these versions into a repo that is accessible by the workload cluster. So I'm putting that Helm chart somewhere, and then I specify this Helm charts. This whole thing could be automated, by the way, but so you have to specify the repo where the Helm chart exists, the chart name, and then the version of the chart. And then on the same place, you also at the at the same place, you are also taking that config map that has values.yaml, and then bundle that package. So this goes into a deployment repo. Sorry about that. So it goes into a deployment repo as a package, and then obviously it will be applied by config sync.
Yeah.
And then so the Helm controller from Flux will be running on the workload cluster. They would take that CL and then start reading the Helm charts, read from the config map that is delivered by config sync, and then that becomes the values.yaml, and then it would take that Helm charts, apply that Helm charts, and now it brings up the network functions, brings up the 3.5GC UPF as if it's just a Helm install on the workload cluster. So now the 3.5GC UPF is running, Helm is done, so they don't care. And at this point, the Nephiel CL goes into the 3.5GC operator, which now has to be drastically changed. So as we talked about with Fiacre, so now this guy is only responsible for reconciliations. So they're not doing deployment. They're not generating any of the Kubernetes resources. They're responsible to monitor the network functions and then see whether or not it matches the intent.
Yeah.
Right. So one example I gave is, what if it doesn't meet the capacity intent? Then it has to reconcile this by, let's say, create another instance of UPF or something, right? So in that case, or if we can, creating different additional interfaces onto the network function. Let's say you have that capabilities. Then in that case, this is locally managed by the operator. It doesn't have to go through management cluster. So now the CL needs to be a little different. So it cannot be explicitly telling us what IP address to use. It may just give us an IP address block. So the operator will be able to allocate from that block, creates the NAD locally, and then add it into NF. So this is more like a day two discussions, but then this gives us a clean separations, because now if a vendor updates their Helm charts, then they're updating Helm charts by updating Helm charts themselves, which is used outside of the context of Nephiel anyway, right? And then now they want to onboard that new Helm charts onto Nephiel, and so this is now version 2. They generate a new package, because potentially there will be changes on values.yaml. So if there's changes in values.yaml, it changes that. So now you have to update the entire deployment. So now the Helm charts get undeployed, so the NF goes out, and then now you're loading a new Helm charts to create this. So the undeploy operations would also be handled. Whatever the update operation is would be handled by Helm, including we have to bring down the whole thing and then uninstall the CL and then generate a new CL or update the CL. We'll do that for an operations. But now the idea, the demarcation points of saying that deployment is handled by Helm charts, and then now anytime vendor has any changes to your Helm charts, it's basically an operation of going through the SDK and update it on the repo.
Okay.
Yeah.
So basically, we are treating Helm as a first-class citizen now.
Definitely, because I would imagine up and until Nephiel becomes so dominant, The Helm would still be the things that are more focused by vendors, and then we'll be able to. We have to kind of draw the line off here somewhere. We can support all the additional Helm features beyond just generating a template.
Yeah.
And apply them on a cluster. All the plugins and all the hooks and all that stuff, we'll probably just say no. We'll say let's convert that into operators. But then at the very least, on day one things, we'll be able to remain using your Helm charts. That you only need to update your Helm charts for that. And then if a day two operation doesn't change, then great. Then you don't have to update your operators.
Okay. Cool. Thanks, Stephen. Yeah.
Yeah. So that's the idea. So
Yeah.
so if your Helm chart changes into like create a new pod, then yeah, you have to also update operators, because now the operator needs to be aware that there's an additional pod that they have to monitor. But then it's a little cleaner. So now you don't mingle. Many people talked about that the 3.5GC operators that obviously I was part of is actually replicating a lot of work that Helm chart does. But then it's much more complicated if you want to change. If you recall in our one, we did make some changes, because when I wrote the original one was based on August last year, and then by the time we did our one, if you remember, Tao did that big update of the to the latest version of 3.5GC with the latest version of towards 5GS Helm charts from Orange. The whole thing was broken, and then we have to rewrite the code. Not rewrite the code, but we have to update the code on the operator. In which case now you may not have to update the operator. If it is, it's basically just an incremental update. Whereas the Helm update would be more natural.
Got it.
We don't have to do like major code updates just because of that. So I'm leaning. I'm an advocate. I mean, I don't get to say whatever it is. I still have to have community consensus. But then if you ask for my preferred mechanisms, I would say let's do this and then see whether or not we can get through a lot of stuff, especially to get more vendors on board using this. This is only pertaining to people who are interested to onboard using Helm. So obviously you're still very welcome to write the entire operator from scratch if you want to. And then the SDK will based on operator SDK, so they can use something a queue builder type experience to write their own operator.
So Stephen, in this case, so let's say that for some reason you have to recreate a workload cluster, or like you have to put in a maintenance. All the logic and all the NF remains in the management cluster, right? Like basically you can treat the workload clusters as ephemeral and destroy them, and eventually you can recreate something. All the logic.
So what we want to preserve is the capability of Nephew, which is a more replicated deployment, right? Except for the variant changes. So we want to preserve that experience. So if you have different workload clusters, or if you want to migrate this workload to a different workload cluster with a completely different new set of inputs, IP address and VLAN, for example, then this is basically a management cluster understanding of like, oh, the deployment has changed into something else. And then now we have to create a different variant, because now even the blocks change, right? In that case, the IP address block may change, because now you go from site A to site B, the actual IP addresses may actually change. So even the block change, not just the individual IP address, but the whole block change. So in that case, you have to go back to management cluster to understand that you are doing a deployment, but now that deployment goes to a different. It's basically a brand. In Nephew perspective, this is like you're removing a cluster, and then creating a new cluster, and then that cluster happens to also match the cluster label, so we're automatically redeployed, and by specializing it based on the new clusters situations, like new IP address block for that cluster. Yeah. So if you have a new cluster, even if you migrate quote unquote workload from one cluster to another cluster, in Nephew perspective, so now anyway, we either NF topology or just generic end-to-end right now, we key off our deployment template based on the cluster label. So if you have a new cluster, the cluster name changes, the deployment repo name changed, So that's basically a new deployment on our perspective. Yeah.
Got it. Thanks.
But then the whole point is, even if we do this, the experience is the same. We are replicating the workflow, the same deployment onto a different cluster, wire management cluster to do the little variant setups. So it matches what is needed to make it work on a new cluster. But then the whole workflow is exactly the same, and it'll be reading from the same Helm charts and the same operators running. Yep. So that's what I would probably advocate.
So one thing is that from the values YAML perspective, everything needs to be generated in the management cluster, right?
In the management cluster, yeah.
Yeah.
Values.yaml pertains to Helm, which ties up with day one, and we don't see any day one operations being modified by operators.
Okay.
Yeah, day one operations is something where a user has to go in and say, hey, this is how I want to deploy it. And that's through a management interface, which is management cluster.
Okay.
Mm-hmm. Yeah, day one operation is where the input to the package, to the vendor package would come in. So that input would only go in through the management cluster.
Okay.
So this is reacting to an intent that is already driven by the management cluster. So it would try to match the reality to the intent. And then if it doesn't involve a reconfigurations, it doesn't go back to the management cluster. That's what we want to kind of draw the line between two. This is more than the SDK discussions. This is definitely something that we would like to push for R3, that we have a much more pronounced and prescriptive even role for the operator. So we now know that we're building operator for this reason, and then we are doing deployment using this, and it doesn't need to be Helm charts. It could be a deployment package where all the Kubernetes resources could be resolved already by at the management cluster level, and then you basically apply the all the Kubernetes built-in resources through config sync to the workload cluster. So this is basically that workflow, the so-called fully shift left workflow, if you will. This is the John thing, if you will. But then you still dump the CL. So now the separation makes it much nicer, because now you make John happy. and then the second thing is we still have day two operations that could be represented by the deployment intent.
Yeah.
Mm-hmm. And then now the monitoring becomes the operator. So it would be, because operator is where the vendor logic kicks in. So it comes in and say that, oh, I know I have that many pods. So now I can set a status by telling you that my UPF is now running.
Yeah.
Mm-hmm. Which Helm doesn't know, to be honest.
Yeah.
Mm-hmm. So yeah, so that's great. As I said, the rest of them, I don't like the workload cluster side of the thing, because it's probably a little nicer for Helm operators from an operator SDK. In that case, you're responsible for generating the YAML start value CL. So now the logic comes down to the workload clusters, where they will take the vendor extension piece and the NF deployment, and then tries to generate the values.yaml and apply them directly on workload clusters. In this case, this is still okay with an operator SDK, but then if we have to support, say, Flux, then this becomes very convoluted, because now you need to basically generate the values.yaml. Your Helm charts repos are per workload clusters, and then the Helm operators, you have two CD engines. One of them pushes the package to the deployment repo, and then another one which is maintaining the Helm charts repo. And in that case, you have Flux CD and confixing or algo CD. Both are doing pretty much are doing the same thing, but looking at different informations. So I think that would be very confusing. That's very convoluted, and it actually goes to the user. User would now have to know which one is doing what. It's something that this is actually what I originally had in the POC doc, which is using workload cluster side. But then yesterday, thinking it through different diagrams, I now more leaning towards option 2.
Okay. So again, what's the difference between option 2 and 3? If you option 3,
option 3,
option
3, so the Helm chart needs to live somewhere still. So in operator SDK's case, you are bundle that either inside here directly, or bundle it inside your package as a local config. So confixing is not going to apply this. We need to put it somewhere. It could be on a repo too, by the way. And then if it's on a repo, then the Helm operators will be reading from a repo. And in that case, the big change here is your input to the operator. So this is all fully operator based. The actuations is done by Helm operators on the back end. But then the operators here would be watching mainly NF deployed, the Nepio CL. The additional vendor CL would be embedded inside NF deployment using config graph mainly. And then we have the extension logic that are TBD, how you do that. There are many different ways you can do that. GLPC is the one that I advocated, which would be implementing stubs. So in that case, it will be reading this and then extract both the Nepio CL and the vendor-specific extension CL, and then put that information to the vendor-specific logic, which would then generate the values.yaml CL structure, which this dummy operators would apply, so that the Helm operators would take over and bring up the network functions. So in this case, there's an additional generations of values.yaml CL that isn't necessarily stored in the in Gig. So you lost the historic reference of what you actually applied to Helm. So compared to option 2, basically, if you're talking about what
who is
the big comparison. Yeah.
the reconciliation here? The operator, the day 2 stuff.
The day 2 stuff would have to be extended directly from here. So it's not as clean as I said. So you don't do a clean separations. So now you have to mingle, because this is now how it works in today. If we have any day 2 so we have, if you remember, we have one day 2 operation thing, which is
Scaling, right?
it could change capacity.
Yeah.
And then which is still not day 2 per se, but let's say it's day 2. It is day 2. It's day 2 that actually started from here, but it's still day 2. And then so in that case, the logic is mingled inside the same operator that does it. The actuation happens to be changing the deployment resource, which is fine, doesn't matter what it is. But then what it does is basically using a major operator to also do both deployments and all day 2 operations. In that case, we need to have a very big thing here to attach to the runtime operator. Whereas, so if in the future, if you want to do monitoring and everything, that all gets sucked into the operator side. So we'll probably make this runtime operators able to hook up with, let's say, observabilities and all that stuff, and then expose informations to the extension, which is very complicated, I would think. Whereas in the second on option 2 case, you're saying, hey, this is all vendors' problem, so we don't really care. We'll still create libraries to allow them to take advantage of the observability pieces if they want it, and then if they do, then they can just read metrics or even logs from observability, and then make a decision to see whether or not they need to do some reconciliations of the current workload. But then the logic is all contained inside the operators. They need to build the operator as an operator through basically operator SDK, because now this is a full bloom operator. There's no dummy operators here to help you do something. This is just you have to also build a day two operator. So now it becomes much more focused for SDK's work. So moving forward, in conjunction with the observability effort, we'll be creating libraries and maybe even auto-generated sample code to help vendors write the day two NF operator. It's much more focused. So it's no longer like, oh, we'll do deployments and day two at the same time. No, this is just day two. We'll help you do this. We'll also know that day two mainly is configuring your network functions, potentially.
Yeah.
And then that channel is something that we would not understand. This is vendor specific.
Yeah.
So you can contain that.
This is definitely cleaner.
Yeah. So that's why when I was drawing the diagram, I actually starting to like this a lot more than option 3, which was what I wrote on this POC document. So eventually I'm going to update this POC document to reflect more on this. But then obviously I need more stakeholder to sign off before we do the work. Because Vim is the one who is asking, let's draw a diagram before we do the POC. I would like to just do the POC directly, but then obviously I would like to get his blessing.
Yeah. Thanks a lot, Steven. Anyway, to wrap up. We just over the time.
Yeah. It's a time anyway, so if there's no more questions.
Really appreciate it. Yeah, it's a great explanation. Thank you so much.
And thank you for attending.
No, thanks.
Thank you.
Bye.
Thanks, Victor.
Bye-bye.
Thank you. Bye-bye. Yeah.
Bye.